Hello and welcome. Today is a meteor shower day from Perseids constellation. However, it is very cloudy and full moon here, so we don't have any chance outdoor. Instead, I'm gonna give a talk on astronomy about motion of sky objects. Here is our plan today. For the majority of time, we're gonna focus on the position of the stars, celestial sphere, and constellation. And for the remaining of the time, we can talk about the motion of sun and earth and why do we have 4 seasons. So let me open by showing you my recent trip to a primitive place for stargazing. This is a campsite called Cosmic Campground in New Mexico. My tent and my setup is right here. As you can see, there's absolutely nobody, no towns or houses except for me in the wilderness. This means there's no light pollution, and avoiding light pollution is so important in stargazing. Now, if you want to join the trip with me, you can watch the video that we previously posted in the description below. So at night, the Milky Way rises, and I set up the telescope for astrophotography just by my tent. The object is called a cosmic palette. It's right here, which is a bunch of stars and nebulae near the Milky Way center. It's pretty cool, right? So you probably want to have this question. How do you know when and where to aim for these stars? Okay, so this lecture, you will have some ideas what to look for and when and where to look for things. This is what this lecture is about. So my secret weapon is to understand the sky is called a celestial sphere. This is the most important concept. Well, actually, it's a backbone of everything we're going to talk today. So here's the Earth, and I am right here. Not the North Pole, not the equator, but right here. So as you can see, my head is 45 degrees tilted upward and my feet 45 degrees tilted downward. But wait, I don't think so because I don't feel so. I am right side up. And as shown in the right picture, my head is pointing up and my feet is pointing down. What tilted is not me, but the Earth. The North Pole, South Pole, and connecting them is the Earth's rotation axis is tilted. So we will keep this perspective throughout the talk today. Okay, so all right, what about celestial sphere? Let me walk you through. Let's go out in the wild, and what can you see? Some landscapes and a generally flat land. Very good. Next thing you want to imagine is that you are standing at the center of a hemisphere made of rocks. So yeah, next time when you go stargazing, please imagine this way. So then next up, you're gonna either use a phone or a compass to figure out where is north, south, east, and west. Then you want to look up in the north. This is a picture I took in one of my road trip in Wyoming. You wanted to look for 7 stars shaped like a spoon. 1, 2, 3, 4, 5, 6, 7. This is called the Big Dipper. And then you want to extend the last 2 stars by about 5 times of their distance to reach another bright star. And this star is called Polaris. So this picture summarizes what you just did. Find the Big Dipper and then the Polaris. Now, you want to understand that the Earth is rotating about its own axis, a line passing through the North Pole and the South Pole. But will you see yourself rotating at all? No. You'll think the sky is rotating instead, to the opposite direction, like this. So this is why the Polaris is so important. The Earth's rotation axis is almost passing through Polaris. This means the Polaris is staying at the exact same position 24 hours a day, 365 days a year. Even during the daytime, it is there, although you can't see it because the sun is too bright. The rest of the stars and entire sky is rotating about the Polaris. How do we know this? This is the picture I took in December 2024 in Big Bend National Park, Texas. This national park is very remote. The nearest hotel is 2 hours away, so instead of sleeping in hotel, I moved all my luggage to the roof rack of the car and sleep in the car. The car is parked on top of a mountain where you can enjoy gorgeous landscape and sunset during the day and stargaze at night. So here I took a bunch of pictures at Polaris and I stacked them. This kind of picture is called a star trail. During the long time exposure, the stars travels around the Polaris and making trails. This is how we know that Polaris is on the rotation axis of the Earth. So now you know how stars move in the sky. We can separate them into 3 different groups. The first group of stars are like this one, star number 1. They orbit around the Polaris for a full turn. They just keep doing that all year long. That means they are always on the sky for all the seasons. The next group of stars are like this one, star number 2. They locate away from the Polaris, so part of their path is above the horizon and part below the horizon. That means they rise in the east and set in the west. Interestingly, there are a third group of stars just like this one, star number 3. They never rise and they always hidden below the horizon. Actually then, you have no idea what celestial object could be hidden there. This idea of hidden stars was realized by British astronomist John Herschel in Queen Victoria's time. He actually persuaded the Queen to finance him for a sailing voyage to Southern Hemisphere to discover what is hidden in the sky. The Queen is very generous and he went. Guess what he saw? This is what he saw, the southern night sky. The bright Milky Way is just like the northern hemisphere, but there are 2 bright nebulae objects beside it, now known as large and small Magellanic Cloud. They are actually galaxies outside of the Milky Way. They are satellite galaxies orbiting around our own Milky Way, just like moon orbiting around the Earth. If you haven't traveled to southern hemisphere yet, you probably haven't heard of them. But just imagine a person who never knew the existence of the moon and then see the moon for the first time. Mind-blowing, right? Alright, let's go back to our celestial sphere. Now, we have a good understanding of it. The Earth is the inner sphere, and the celestial sphere is the outer sphere. Inner sphere does not move, at least from our perspective, and the outer sphere is rotating relative to us. But the next question is, there's so many stars, right? How can we describe the location of them? The answer to this question is actually quite natural. Just to think there's so many different places on Earth, and how do we describe them? There are 2 methods. The first method is what we do every day. Just divide the Earth into a bunch of regions with names and call them name. If anybody wants to ask you where do you come from, you can answer I'm from United States, and that's a name. But if that's not accurate enough, you can say, hey, I come from Washington, D.C. These names do not represent a single point, but a region or a collection of points. It's not the most accurate way to describe the location in the world, but for everyday purpose, that's enough. And we're going to talk about the second method later. So, we do the same tricks to locate the stars using constellations. Imagine constellations just like countries. The only difference is that they live on celestial sphere rather than on the Earth's surface. And just like we have a world map of different countries, yes, we have a world map of constellations. Take this one, Leo constellation, for example. You can see there are straight and zigzag boundaries around it. This is a Leo constellation. Any stars inside this boundary belongs to Leo constellation, and any star outside of this boundary does not belong to Leo. The brightest star in Leo is labeled as Alpha Leo, the second brightest one, Beta Leo, and Gamma Leo, and so on. You can imagine Alpha Leo is the capital city of the Leo country. Then Beta Leo is the second largest city, and so on. Okay, let's take a look at another constellation. The northernmost constellation is Ursa Minor, in short UMI, and the brightest star in Ursa Minor, or Alpha Ursa Minor, is actually the Polaris. Here is the Big Dipper. The Big Dipper belongs to Ursa Major constellation, and the stars moves very slowly on the scale of 10,000 years. So at least for the next 1,000 years, there won't be any noticeable change. So that means this map is fixed. However, there are some objects that move. For example, a planet will move in the star background. And also the sun moves, and we're going to talk about the movement of sun later. For now, you want to know that the sun moves in the star background along this red path, which is known as ecliptic. Here are some facts about constellations. There are a total of 88 official constellations covering the entire celestial sphere, no overlaps and no gaps. And just like we have larger area country in the world like Canada and Russia, there are also larger area constellation. The largest constellation is Hydra, and the smallest constellation is called Crux. Actually, you cannot see Crux from the northern hemisphere. You have to go to the southern hemisphere to see Crux. And that's why it's so unique that it put on the national flags of Australia and New Zealand. There are 88 official constellations in total, but only 30 of them are strictly northern and 30 of them are strictly southern. And the rest 28 can be seen anywhere. So it's about 1/3 and 1/3 and 1/3. Okay, about a constellation, there is a big caveat. Constellation only tells you about directions. They have nothing to do with the distance. So for example, in the picture here, you see a bird and also a sun overlapping, right? So let's say it's in November time and the sun is in the background of Scorpius constellation. The bird is much closer to us. Can we say the bird is also from a Scorpius constellation at this moment? Well, technically yes, because the constellation is only about directions. So the Scorpius constellation should contain everything in this direction, that's including the bird, the sun behind it, or the stars behind the sun, or the remote galaxies behind those stars till the end of the universe. Distance is another important topic in astronomy. Just figuring out the distance from Earth to the sun, it costs generations of people and unbelievably epic efforts. But that's not our topic today. Now we want to talk about 12 zodiac constellations. They are very special. When Earth is orbiting around the sun, from Earth's point of view, the sun located at different part of star backgrounds. In December, when Earth is here, Earth looks at the sun and the sun is in the background of Leo constellation. And 2 months passed when Earth orbiting to this location and Earth look at the sun at a different angle, and we think the sun is in the background of Scorpius. That's why all year long we will see the sun actually go along this path, which is known as ecliptic, and the ecliptic passing through 12 zodiac constellations. There are Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpius, Sagittarius, Capricornus, Aquarius, and Pisces. Apparently, they are associated with specific time, and also, you guess what, birthdays. So the days of birthday is exactly when the sun passing through the zodiac constellations. For example, for any people, the birthday from July 23rd to August 22nd, they belong to Leo constellation. This is exactly the time that sun passing through Leo constellation. You also know that people with different constellations tend to have different personalities, and those personalities are predictable. But this topic belongs to astrology, which is not our topic today. There are a total of 88 constellations. 12 of them are zodiac. That means we have 88 minus 12 equals to 76 non-zodiac constellations. Among them, Orion is probably the most famous one. You can recognize it in winter sky from 3 belt stars. The rest of stars together with a belt shaped like a hunter, with bow in one of his hand and a stick in another hand. On the right hand side, I took this picture from Assateague Island, Maryland in the winter of 2022. It is about 3 to 4 hours drive from Washington DC, and one of the relative low light pollution place you can think of in that area. As you can see, I also brought my telescope with me to take pictures of Orion constellation. So in my eyes, when you talk about constellations, the first thing coming to my mind is not the personalities, but rather the objects in that constellation. So for example, Orion has Horsehead Nebula near the one of the belt star, and also M42 nebula, aka Orion Nebula, below the belt. The nebula is so bright that it's easily visible by naked eye. Next time you do stargazing in winter, just pay attention to that. Now let me show you the picture I took for these objects. This is a Horsehead Nebula because it looks like a head of a horse. It's actually interstellar dust with a special shape. On the left, it's another nebula. Do you know the name? Yes, you guessed it. It's called the Flame Nebula. And this is M42 Nebula, or Orion Nebula. Under telescope, it is even more gorgeous. The interstellar dust is lightened up by a group of new burst stars. Okay, and remember you saw this earlier. Yes, now you can see this is the Scorpius constellation. This 2 point is the Scorpius pinch, Scorpius head, Scorpius heart, the body, and the toxic tail. The cosmic palette is at the heart of the Scorpius. And here's the cosmic palette again. Because it's very close to Milky Way center, you can see the star density is a lot higher. There are even more denser interstellar dust. Dark region here is where the dust is covering the starlight, and the bright colorful region is the dust lightened up by nearby stars. Because a star has different color, they lighten up the dust with different color. So speak of Milky Way center, there are numerous nebulae in that region. So for example, you are looking at Lagoon, which is the bottom one, Trifid, which is the top one, which are even closer to Milky Way center. They belong to Sagittarius constellation, which hosts the center of Milky Way, and also including a supermassive black hole. This black hole has 4 million solar mass, and the entire galaxy, including us, is orbiting around it. We can also take pictures from outside of Milky Way galaxy. What you're looking at here is another completely different galaxy known as M31 in the constellation of Andromeda. This is the closest neighboring galaxy to us and is even bigger than us. The supermassive black hole at the center of it has 2 billion of solar mass. which is almost 1,000 times of ours. And what is interesting is that M31 also got two satellite galaxies, which are M32 and M110 orbiting around it, just like large and small Magellanic clouds orbiting around our own Milky Way. Okay, so this is so much about constellations. We were talking about how to locate the stars. The second option is to using accurate numbers or coordinates. Using coordinate in a spherical system sounds intimidating, but don't worry, we have been using it in our everyday life. And yes, it's a latitude and longitude system of the Earth. Astronomists use a very similar system called declination and right ascension. Declination is just like latitude, like what you see on the left. The only difference is that the declination is labeled on a celestial sphere rather than on Earth. And otherwise, it's very similar. On the top is called North Celestial Pole. It's at 90 degrees north. And the southern point is called South Celestial Pole, and it's 90 degrees south. 0 degree is called celestial equator, just like equator on Earth. Similarly, the right ascension is just like the longitude. The only difference is that the longitude is on Earth and it has 360 degrees. Right ascension is on celestial sphere, and also it uses hours, because one full turn of the sky takes 24 hours. It is very convenient to note this way. Now, let's revisit the roadmap of constellations, and now just pay attention to the coordinate. The vertical axis is the declination. It's from positive 90 degrees to equator, which is 0, and to south celestial pole of negative 90 degrees. And the x-axis is the right ascension. And you can see the right ascension changes from 24 hours to 21 hours, 18 hours, and all the way to 0 hours. And also, there is a fun fact that you want to pay attention to. Now, let's try to find out where is Orion constellation. Aha, it's right here. ORI in short for Orion. The belt of Orion is right on the celestial equator, and as you will see next, it means it can be seen in all the places on Earth. Okay, so why do we care about right ascension and declinations? Why they're important? Because right ascension and declination determines whether a star can be seen all seasons, or seasonal visible, or not visible at all. And they also determine for seasonal visible stars which season that you can see them. Now let's explain why. Okay, so we have discussed several group of stars based on their movement before. Now let's revisit. So for the first type of star, star 1, just because their declination is so much close to the North Pole, we can see it all seasons because they just rotate like this year long. And then for the second type of stars, like this one, star number 2, they rise and fall. And this is actually a type of seasonal star. And let me explain why. Because the star, they rise roughly in the east and sets roughly in the west. And if you want to see the star, you don't want to see it during the day. That means you want a star to avoid the sun. Okay, so let's say in the summertime, the star is over here and the summer sun is over here. This is summer sun's position in the ecliptic. And when the sun is down here, it's at night. Yes, of course, you have no problem in seeing this star. But 6 months later, the sun moves to this winter position in the ecliptic. Then the sun rises with a star and sets with a star together. What does this mean? It means you cannot see the star because it appeared in the morning. So that means this summer, this star is a summer visible star. And similarly, you have winter visible star located right here. So as you can see, along this ring, the stars have different right ascension, and the right ascension determines which season you can see it, right? And finally, if the declination of a star is too much south, then they cannot be visible no matter what season. Okay, so in short, declination determines whether star is all season visible or seasonal visible or not visible, and the right ascension determines for seasonal visible stars which season you can see them. And finally, an interesting fact is here is celestial equator. Celestial equator and the Orion belt can be seen anywhere on Earth. Okay, and there is another important application of right ascension and declination. It's actually on telescopes. As you can see, my telescope has two possible rotation axes, and the axis is directly named by declination axis and right ascension axis. So that means you can aim to any point, any object you want by telling the telescope to point to a specific right ascension and declination angle, right? But in order for this to work, you have to align the right ascension axis to the real Earth rotation axis, and this is called polar alignment, like what you see on the right hand side. So here my son is using a polar scope to aim for the Polaris. As soon as the Polaris appear in a specific location in the polar scope, the mechanical axis of the telescope coincided with the Earth rotational axis, and then the polar alignment is done. Okay, so this is so much about part 1. Let's do a quick summary. I talked about celestial sphere, which helps you to locate the position of stars. And then we talked about star location can be noted by two methods. Method 1 is roughly noted by names, which is constellation. And also you can accurately note their coordinate, which is a right ascension and declination. Okay, so for the rest of the time, let's just quickly talk about the motion of Earth and 4 seasons. I want you to put two questions in your mind. So question 1, because the Earth is spinning about its own axis, right? So Sun is always lighten up half of the Earth and leave another half of us in shadow. The first question you want to ask yourself is, does it mean that the daytime and nighttime always evenly split? And then question 2, we always know that the sun can show us direction, especially if you don't have any compass around you. But does the sun always appear in the southern direction? Okay, so these two questions put in your mind when you watch the next content. Okay, so we are going to reveal those answers in the following content. So what you are looking at here is the Earth rotation and revolution, aka spin and orbit, about its own axis and about an axis in the space. So as you can see, these two spinning axis and orbiting axis, they don't coincide. Actually, there's a tilt of an angle about 23.5 degrees, and it's this angle caused 4 seasons. So as you can see, there's 4 special places of the year when Earth is at different locations, right? So this point is June 21st, and it's called summer solstice, and the opposite of that is winter solstice, and the other 2 is called vernal equinox in March 21st, which is spring, and then autumnal equinox in September 21st. Now let me explain seasons and why we shouldn't expect evenly split days and nights. So in the middle is the sun. Let's focus on the right, on the left, June solstice, and here is the Earth. As you can see, there is a blue line. The blue line is a boundary of day and night. On the right hand side of the blue line, it's the day, and on the left hand side of the blue line is the night. Now, you also know that Earth is keep rotating about its own axis, which is the black one, right? And imagine you are right here. Let's say you are at this point on the Tropic of Cancer. Then when you keep rotating about the Earth, you just follow this purple line. And guess what happened? Can you see that the length of the purple line in the shade is actually shorter than the length of purple line lit by the sun? That means in June solstice, you have longer daytime than nighttime. And if you are in the southern hemisphere, the situation is opposite. You have shorter day but longer nights. Okay? And the entire situation is opposite when it comes to December solstice, right? Which is the winter for northern hemisphere and summer for southern hemisphere. Alright, so this already answers the first question. Does the day and night split evenly? The answer is no, they do not. Okay, then let's try to figure out the second question. Does the sun always appear in the south? This is a bit difficult question to answer, but luckily we already have the concept of celestial sphere, so yes, we can do it. So let's just revisit the ecliptic concept. This is the solar path in the background of a star. We already talked about that, right? So now we would like to put this ecliptic in celestial sphere. So this is a celestial sphere, and the ecliptic is actually this tilted red path. And the sun stay at different position of this ecliptic throughout different season of the year. And for vernal equinox, the sun is here. Summer solstice, the sun is here, and then fall and then winter. Keep in mind that the solar movement along this ecliptic is very slow. It's one turn per year. But also keep in mind that Earth is also rotating. The rotation speed is much faster. It's one turn per day. So let's say when sun is here at summer solstice, and just because the Earth is rotating, so sun will follow this path, okay? And after when it hit autumn equinox, for example, the sun becomes to here, and then the solar path will follow this completely new ring, right? And until winter time, the solar path is a new path. Now let's just take a close look of solar paths for different seasons. This is the solar path for summer solstice, or around June 21st. You can see that the sun has the longest path, so the daytime is the longest. It's actually more than 12 hours. And this point is at noon, so you can see the sun is actually closer to the top of you, which is known as zenith. Because the sun is closer to zenith, that means the solar power per area is high. That's why summer is so hot. And also note that the sun rises in the northeast and then goes south, and then sets at northwest. This already answers you the second question. Does the sun always appear in the southern direction? The answer is no. The sun can appear in northeast or northwest. Okay, let's move on to springtime and autumn time, fall time, also known as vernal and autumnal equinox, which are March 21st and September 21st. And as you can see here, the solar path is exactly the celestial equator. What does that mean is exactly half of the equator is above the horizon and half the equator is below the horizon. That means daytime is exactly 12 hours and the nighttime is exactly 12 hours. Okay, and also you can see that at noontime, solar angle moved away from zenith right above you, so that means decreased power per area. That means, okay, so springtime and fall time, the noon is not as hot as summer. And finally, you can see that the sun rises exactly from east and sets exactly at west. Okay, so finally winter time. Winter solstice is December 21st. and this is solar path. As you can see, it's so short. That means the daytime is much less than 12 hours. And solar angle at noon is so shallow because so far away from zenith. So the solar power per area is low. That's why the winter is the coldest, right? And the sunrise actually at different location. It rises from southeast and sets at southwest. Now, having understand the solar path for northern hemisphere, right? Not North Pole. Let's just take a quick look at what happened at the North Pole. So this is celestial sphere at the North Pole in comparison to the celestial sphere that we are familiar with. Because you stand on the North Pole, then on top of you, zenith is also the North Celestial Pole. Yes, you will find the Polaris star is right above you, and then all the celestial objects will circulate you in this horizontal manner. And what this means in solar path is the solar path either circulate you in this horizontal path above you or in this path below you, depends on the season, right? So for the summer season, the solar path just go around you, which is known as the polar day. And when the sun goes down, it's known as a polar night. So at the North Pole, there is only one sunrise and one sunset per year. This is the polar day looks like in Arctic Circle. The sun is near the horizon. It's not rising, it's not setting. Of course, the sun moves, right? It doesn't stay there. So the way sun moves, it just moves horizontally around you for 360 degrees. And polar night is actually a long time that sun will never rise, and it's the best time to see polar night. Okay, so we have just finished part 2, and let's do a quick summary. So we talked about Earth's rotation and revolving, and showed that the rotation axis tilts by 23.5 degrees from the revolving axis about the sun. And we also talked about why there are 4 seasons because of the axis tilt. And finally, we talked about polar days and polar nights in Arctic or Antarctic circles. Thank you very much for your attention.